Hi, just a quick message before the next episode. My audio is unfortunately terrible. However, my co-host Laura and our wonderful guests' audio is perfect. So listen to them. Don't listen to me. Enjoy the episode.
Welcome to Cloud Native Compass, a podcast to help you navigate the vast landscape of the cloud native ecosystem.
We're your hosts. I'm David Flanagan, a technology magpie that can't stop playing with new, shiny things.
I'm Laura Santa Maria, a forever learner who is constantly breaking production.
Nervous about cloud native networking? Intrigued by Istio? Today, we're chatting with Matt Turner and Marino Wijay, both contributors to the Istio project and advocates for the new Ambient Mesh architecture provided by Istio.
With the graduation of the Istio project and the alpha release of the Ambient Mesh architecture, we have a lot of questions to ask that Matt and Marino can't wait to answer.
All right. Hello, everyone. Welcome to this little session here on Cloud Native Compass. My name is Marino Wijay. I am a platform/developer advocate at Solo, and I focus in on network technologies spanning from the lower levels all the way up to service mesh. And I'm here and very excited to talk about Ambient Mesh with y'all.
So excited.
So
I can tell.
Yeah. Where's the excitement, Marino? Like, come on, let's go.
So I'm Matt Turner. I'm a software engineer at Tetrate. I focus on fairly similar stuff to Marino, I guess, looking at service mesh. I've been into Kubernetes, containers, cloud native stuff for quite a long time now. Also super excited to talk about Ambient Mesh. It's a really interesting development. Lots to cover.
All right. Well, let's just kick it off. You both said Ambient Mesh now, so I've now said it for the third one, which means we can actually properly start. But for anyone who is not aware of what is happening in the service mesh space, particularly around Istio, can we give them the 30-second to minute overview of what is Ambient Mesh?
Sure. Yeah. So Ambient Mesh is a new mode of operation in the world of Istio, and it was developed because there were a lot of different interesting patterns that we were seeing with workloads that just never really saw a benefit to using a sidecar. A service mesh normally would deploy a sidecar alongside your main application container, but we realized that there are certain patterns that just don't fit with the sidecar model. So enter Ambient Mesh, where we're effectively removing the sidecar, but still presenting the service mesh-like capabilities, but from a different lens and in a different architecture. At the end of the day, Ambient Mesh is still service mesh. It just creates operational simplicity and allows you to cut back on resources while still retaining all the benefits of what a service mesh offers.
I guess that's probably what we'll get into. So absolutely, Ambient Mesh is a new mode. So a new install option deployment topology for Istio. It's all still Istio. That's the service mesh it's been done in. There's no reason this couldn't be applied to other meshes, but this is an Istio project we're talking about. I probably have some comments on on pretty much all of the sort of features that were listed there. Like we can debate those. But yeah, like the 50,000 foot view is that it's a new deployment mode, a new architecture for Istio that, like Marino says, removes sidecars and replaces them with a different way of doing things on the data plane. It's still the same Istio control plane.
Okay, so Ambient Mesh removes sidecars. I would hope that this brings substantial, maybe not directly performance, but at least compute and memory optimizations across the cluster. Because, if people are running, let's throw out the wonderful 110 number, right? 110 pods in every one of their nodes, and they've got 10 nodes. We're talking about, oh my God, I have to do maths, it's only multiples of 10, but 1,200 pods, which could be potentially 2,400 containers if they're in sidecar mode, right? So while I'm sure these sidecars have historically been optimized to be very lightweight, they're still containers at the end of the day, which means they still do have a memory footprint, a compute footprint, and so forth. Is that directly the benefit of Ambient Mesh, or is there more to it than that?
There's much more to it. So let's think of the classic example of the race condition. So you have certain applications that need to respond almost immediately, but when you inject a sidecar into that model, one of the challenges that you have is that now you have this race condition of the sidecar versus the application container that have to come online. Who comes online first? There might be situations where you have to set what they call a hold application timer in the configuration to prevent your main application container coming online before your sidecar. In that situation, what ends up happening is the Istio init container cannot redirect IP tables so that traffic can go through the sidecar first before it gets to the application container. Actually, that doesn't even happen. Your application container is directly interfacing with other services, and it's not even part of the mesh at that point. So one of the approaches that Ambient Mesh takes is you could still inject services into a mesh without having to deploy this sidecar. And what ends up happening is there are resources that sit outside of the application itself or the pod itself that set up the redirection of traffic. Now, there are some components that are involved that make this possible. For example, are you all familiar with the Istio CNI? The Istio CNI is more of it's not a CNI replacement, just to be clear. It's not a container networking interface plugin. It's actually an add-on that you associate with Istio because there are certain situations where the security teams do not want you to hop into your pod manifest and specify privileges for those application containers from a security standpoint. So you would use the Istio CNI to do a lot of this, give it access to be able to modify those changes at the host level, IP tables rewrites, to allow for pods or applications to communicate in Ambient Mesh. Even outside of Ambient Mesh, when we're talking about having sidecars present with that particular security constraint, the Istio CNI will help with the redirection as well without having to modify any sort of pod manifests. Now, when you think about that for a second, when you actually think about what that truly means, it just means that we're just redirecting traffic no differently than we would do inside of the actual pod itself if a sidecar was there, because that's the operation that goes on anyways. Now, here's the other consideration though. So you don't have a sidecar anymore in Ambient Mesh. Who's actually doing the mesh stuff? Where do things like MTLS show up? How do we gain our observability? What happens to things like authorization policies? Now, that's what's been addressed in Ambient Mesh through some artifacts, 2 new artifacts. One is called the Z-tunnel, and the other one is called the Waypoint Proxy. Now, the Z-tunnel is a node-level proxy, you could say, which actually used to be Envoy a long time ago, and they've rewritten it in Rust just to focus in on things like layer 4 policy and connectivity, providing the MTLS, and even providing authentication to other services. But what really interestingly happens here is that when you have traffic that has to go between nodes and you have, service-to-service communication between those nodes, your traffic actually traverses these Z-tunnel pods that exist at the node level. And these Z-tunnel pods, again, because they exist across all the nodes as a daemon set, they are forming tunnels to each other. Now, are any of you familiar with tunneling technologies like IPsec or VXLAN? Okay. So it's a so these tunneling technologies basically create a virtual private laneway or network, VPN basically, to allow for a dedicated lane for your traffic to move about without folks being able to inspect and sniff that traffic and know what's going on behind the scenes. They won't be able to understand what payloads are being sent because all of that is jumbled and encrypted anyways. Now, we want to maintain the encryption because we want to maintain that security posture altogether. But the creative way that we approach this, or that the open source community approached this, is by creating a brand new tunneling protocol called HBone, or the HTTP-based overlay network encapsulation protocol, which is another fancy way of saying, hey, let's just deploy VXLAN/Geneve 4 Z tunnels to form their tunnels to each other and create that laneway, which is all what's going on. But here's the kicker here. So all of this is layer 4. When you start to realize that, hey, I need to inject some layer 7 policy, I don't want to run get operations against this service, I need to provide some sort of mechanism to prevent that, this is where I deploy a Waypoint proxy, which is still Envoy based. Now, I'll stop there because there's a lot more technical details around it, and maybe Matt might want to expand on that a little bit more.
Yeah, I'd probably like to go right back to the beginning, right? So, the race condition that was mentioned is, say that's an implementation detail. It's definitely real. It's definitely a concern. There is at the moment, there's the solution to that is to hold the application back. There's, I think, Monzo open source, like a wrapper that does that, like an init wrapper that does that. There's various sort of ways to fix it at the moment. But there's a cap out to fix this in Kubernetes. So this is kind of well known. It's understood. A network sidecar is not the only kind of sidecar container that has this issue. So there's a KEP in progress to identify like the main application container and the sidecars and ensure that ordering, right? So to me, that's an implementation detail, like it's being fixed. I'm not sure the thing about the init containers is actually true. Like they are guaranteed to run before any of the sidecar, any of the sort of main runtime containers run, even the sidecar. So it's the init container that sets up the interception, the IP table's interception. And that is guaranteed to run to completion before the application container runs or the sidecar. So again, I'm not quite sure about what's maybe going on there with the security. Like those IP tables rules would always be in place. Sure, the sidecar might not be ready by the time the app has come up, so the traffic will get black holed, which is an availability concern, but it's not a security concern because we know those interception rules will already be in place. What Istio CNI is, like Marino says, it's not another like CNI, like another actual overlay network, but it's a CNI wrapper because you can stack these CNI plugins. So it'll what it does is it basically runs. So the job of a CNI, the job of an actual like CNI plugin is to just provide a network interface into the pod, right? When the pod's being made, your CNI plugin will make a tap or a VETH or whatever your underlying, or do some eBPF, whatever your underlying network wants. And you can stack them. So if you put the Istio CNI in first, it'll just run first. It doesn't actually make a network interface, but what it does is set up those IP tables interceptions rules so that you don't need an init container. And the argument for that is folks don't want to give the init. So the reason the init container exists is firstly to fix that race condition. And secondly, so the init container can have the high privileges you need, like the capnet admin that you need to set up IP tables. Some folks aren't even happy with that, with that init container having those permissions. So you can use the CNI just to run that privileged code like somewhere else at the host before the pod comes up. So again, kind of implementation detail, but both of those get rid of that. Get rid of that race condition, and like the pod manifest is never needs to be modified for either of those solutions. Like it's modified at runtime with the init container, but that's done transparently by Istio. So yeah, there's like a lot of implementation details you have to understand to really kind of grok what's going on here and why you might choose between the two different modes.
So it's clear that it's going to be a choice between, specifically, that's what you're mentioning. Like you don't really run them together on one cluster, correct? Like a sidecar implementation and an ambient mesh implementation.
You can actually, namespace by namespace. Okay. Is that right, Marino? Is that the I guess.
Yeah, that's right. I mean, the way you go about enabling sidecar versus non-sidecar is just a label that you affix to the namespace itself. So in the case of sidecars, you do the Istio-injection equals enabled label, whereas the for ambient mesh, right, in another namespace, you actually specify a data plane mode equals ambient. Can't remember the actual label, but there's actually a very interesting difference between the two. So the race condition was one particular example of an issue, a very corner case, but there's another issue as well. If you're already running workloads that are running in production today, to inject a sidecar means you have to do a rollout of your deployment so that the sidecars can be injected into new pods that get deployed, which actually can be a little bit of a hit in terms of being online. So in the situation where you're not deploying sidecars, but you're using ambient mesh, none of that ever happens, because all we're really doing at this point is, and I'm going to use an example from way back in the day of IPsec. In IPsec, right, when you formed tunnels, one thing you had to define was interesting traffic. Those interesting traffic would be defined through access control lists. And as long as your whatever proxy or gateway that you're using can identify that this traffic has to be matched to be encrypted and tunneled, then that traffic would proceed to go through encrypted. This is very much the same way how ambient mesh would work, is that you have a namespace that has been labeled for direction towards ambient mesh enabled, but also direction towards these Z tunnels. So traffic will get redirected, but this doesn't happen inside of the main application container at all. In fact, this is where the Istio CNI comes in to help with that. So it's not intrusive, especially when it comes to production workloads. You could just deploy ambient mesh. Hold on, there's a caveat here because ambient mesh is still experimental at this point. I wouldn't say just run it in production. But having said that, the goal and the mindset here is to prevent production outages or downtime as you're deploying services into your mesh.
So, I mean, just to clarify, I guess that like sidecar is never intrusive either. Like you never need a change to the application code or even to the application like deployment YAML that you submit to the API server, because the mutating webhook emission controller will go and alter it for you. So yes, those IP tables exist, but they don't affect like the container. They exist within the pod because a pod is a set of C groups and a set of namespaces. IP tables rules are scoped to a network namespace, so they exist in that namespace, and they live because they've been set up either by the Istio CNI or the init container. They persist within that namespace, and actually when the application comes up, it has no idea that they're there. The other thing about rolling it out, like retrofitting at runtime, like it is, if you're running an application and you're in production, and you want to retrofit sidecars to something that's running, I would probably say as an ops person that's maybe a bit of a bad move. You should try it in staging and stuff first. But yeah, if it gets to the point in production when you want to roll this out, I guess I'd kind of challenge the idea that's going to be disrupted, because you've got a Kubernetes deployment. So if you change the manifest, you just do a rolling update, it's going to honor your min unavailable, your max unavailable. It's going to honor your pod disruption budget. Like if you're in a position where you can't, one by one in a controlled manner, restart these pods. Remember Kubernetes builds in a surge to keep your availability, your load carrying capacity. If you're in a position where you can't do that, then you can't do any disaster recovery. You can't release any new versions. You can't do any upgrades. So I think, anybody who's deployed into Kube, anybody who's cloud native is not kind of staring at like that Windows box in the corner that they really can't touch. So yeah, like Ambient does let you sort of retrofit the networking under the carpet while it's running, but I've not come across anybody for whom that's necessary. Anybody who can't just do a Kubernetes rolling update. Yeah,
lots of interesting details there, and I'm going to do my best to recap all of this in like 30 seconds because it helps me understand, right? I want to make sure I understand what's actually happening here. Although I did first, in fact, there's two things I want to cover first. Let the record show I was not the first person to say Rust.
Yeah,
just throw that out there.
That's true.
I was waiting for you to interrupt. Sidetrack the whole conversation.
I was like, yes, 8 minutes in and I wasn't first. Anyway. And secondly, obviously the comment about the Windows box that we can't touch. Like, it just made me have like a flashback to like when we used to work at offices and I used to do a lot of operational stuff myself. It's like there was always this IP address we could ping, but nobody knew what it was. And I always felt like, every office had one of those at one point. Anyway. So, recap. Just so that I understand, right? We have Istio, we have sidecar-based container mesh. It uses init containers to do all of the IP table rules that are needed to satisfy the constraints for the pods to be able to be part of the mesh network and take advantage of all the mesh stuff. Now, there's a whole bunch of reasons of why that may have to change. There's obviously compute and memory things that we can optimize. There's some security concerns, and there's just application availability things that disappear if we don't need to worry about it, of course. Now, Ambient Mesh wants to change that model. And while you can run in hybrid, is what we've heard, I suspect most people will just want to move towards Ambient Mesh. I know you said don't ship it to prod, but I'm already thinking of doing it today anyway. So, it might be a little bit too late for my cluster. But it runs a Z-tunnel, which is a new proxy written in Rust, that is, assuming it's just a daemon set, which is part of the Istio deployment. And instead of injecting sidecars, you had mission controls or otherwise, it handles all the IP tables rules as the pods come up and come down, etc. And we still have our complete mesh network. Or maybe the Z-tunnel doesn't handle the IP table rules. I'm not entirely sure at this point. But it does things. There was also that second component that Marino mentioned, which was
the waypoint.
The waypoint. Can we get, what does that do?
So the waypoint is the one that actually processes a lot of the layer 7 heavy duty lifting or heavy lifting. So for example, you specify an authorization policy normally in Istio that prevents services from doing certain things to other services. And we're talking about HTTP. This is where the Waypoint Proxy come in because a sidecar used to do that for us. So the thing about that Waypoint Proxy is it has to run Envoy to be able to achieve this. I mean, I'm sure in the future they might change up the implementation, but I can't confirm that because I don't even know what the roadmap looks like. But I will say that anytime that you have that requirement to deploy layer 7, what ends up happening is you actually deploy this at the destination workload. So for example, you have workloads that exist on 2 nodes and you have workload A that needs to communicate with workload B, but you need to do some sort of HTTP request, some methods, whatever it is. But you also want to prevent service A from, deleting any sort of information off of service B. So you would implement a policy, normally a layer 7 auth policy. Now, who enforces that actually ends up being the Waypoint Proxy, which gets deployed at the destination node for that destination workload. And this is based on a per workload basis. Now, here's the other interesting thing, that Waypoint Proxy actually leverages the latest Gateway API standard. So the Gateway API standard is one that allows us to effectively bring in a lot more of a cleaner ingress into our cluster, plus be able to do things like TLS termination, and even things like we could even do the releases that we would want to through this Gateway API spec, where previously it was a little bit harder to achieve because you need ingress controllers, ingress resources, and a lot of interesting math. That being said, with that Waypoint proxy, it's deployed on a per needed basis. If you don't need it, if you're not running any sort of layer 7 services or don't have that requirement, you drop it, because it is one of those resource intensive artifacts that get deployed to the cluster. And when you get to that level of scale where everything needs layer 7 proxy or layer 7 authorization or something, this is where you're evaluating your design. Like, maybe we should probably be using a combination of sidecar and sidecar lists for certain situations. This is going to be a design versus, let's just do it. Now, one other bit about the Waypoint is that it's actually in line of traffic with the Z tunnels, and it actually terminates a Z tunnel at the local node. So for example, service A talking to service B between two nodes, service A would traverse one Z tunnel on its local node co-located with it, and service B would receive that traffic, but first that traffic has to pass through the destination node Z tunnel, which then tunnels to the Waypoint proxy. The Waypoint proxy is what releases that traffic and then basically passes it along to the actual workload.
Yeah. So the Waypoint it actually is Envoy, right? So currently in a sidecar model, all of the sidecars are Envoys. With Ambient, you've got a Z tunnel which does layer 4 stuff, one per node, and then there's a Waypoint. The per service account, right, for isolation. So there's a Waypoint per service account, so kind of per workload that you jump through. I guess the thing is you kind of always have to jump through it, because okay, if you don't do layer 7 policy, then fine, but this is an identity based mesh, right? If you're not doing like layer 4 policy is the reason you're running a service mesh is probably because you're finding that insufficient. And also, if you want anything that interacts with HTTP, so if you want any observability of particular API endpoints, you want to even understand what's a request response, what's a success and a failure. If you want any kind of distributed tracing, you've got to be involved with HTTP, passing HTTP. So while the model is theoretically good, like realistically, basically everything is going to go through a Waypoint. So into like those latency saving claims, those kind of resource saving claims maybe don't apply for real world workloads, because you kind of always want them. And then you get into the issue that the Waypoints are shared. So all of the security guarantees around having a dedicated like firewall, a dedicated policy enforcement point, agent per workload go away. Like, it's not even really, it's not zero trust anymore, right? Because a pod is trusting something. It's trusting a shared Z tunnel, which is actually shared across tenants because they're per node. And that thing is holding the keys and the certificates for like all of the workloads it represents. And they're also trusting a shared Waypoint. And Envoy, remember, was designed as a sidecar proxy, so it like makes no attempt to mitigate noisy neighbors. It has no resource management, of its own. It again represents a confused deputy, like a place for lateral movement. So I think that's the big trade-off that I talk to folks about, is you can get some theoretical resource, wins on Ambient. But again, I would kind of challenge that with there's some sort of kernel internals to think about. Modern systems are quite complicated. But the trade-off is that security posture.
I just was going to say real quick, for people who are listening and are very, very confused by the references to layer 7, just to note, we'll put a link in the podcast description about what the OSI model is and what all these layers are. So don't worry, you can read more about that. I don't want to go deep down into some very, very basic stuff, but this is at the very, very top of your networking model on the application layer. We're talking with layer 7. I don't know how far down the layers they go with sidecar and ambient mesh. So if you want to just, I think I heard like there was some stuff at layer 4 and layer 3, but just to double check.
There only
if
are
you
two
need
layers,
it,
right?
the resource. What?
Layer 3 and 4 are pretty much the same, and then layer 7. Nobody else even knows what layers do, right?
Yeah, no, the others are.
Oh, Well, depends on who you're talking to and what her history is. But regardless, just so that you know, we will put a link in the description. All right, go ahead.
Yeah. So one thing I was just going to add, and I agree with Matt. Like there are definitely trade-offs when considering something like ambient mesh, right? And it really will come down to your own personal or your business requirements, what you need, if you have the suitable amount of resources, if you don't need layer 7 authorization. But the one thing I wanted to clarify is the element of identity. So even in that shared service model, there is tendency that exists both at the zTunnel as well as the Waypoint level. And this is derived through the whole, Kubernetes service account token generation, and how zTunnel and Waypoints will assume the identity of those given workloads for that given traffic path. Even if, for example, you have that shared service model, the idea behind what zTunnel and Waypoint are offering up is that slice of that part of that laneway. So it still maintains separation and isolation. But here's the other consideration, right? Like this has come up a lot. What happens if your node gets compromised? Now I can have access to zTunnel. Now I can, impersonate zTunnel and then direct traffic elsewhere to another environment that you wouldn't even know of. If you're at that point, you haven't spent the time to lock down your Kubernetes environment, and you've just basically given access. Root access is probably the most dangerous thing you can have inside of your cluster. So in those situations, it's not about service mesh at that point. It's about how you've built security practices and posture into how you run Kubernetes. So in the situation where you have workloads that exist within a node that are communicating, the fascinating part about it is they're never going to pass through a zTunnel, right? They're going to communicate directly on the wire through the CNI. And even though they're a part of the mesh, there's no MTLS going on. There's plain text traffic going on. But that's not the issue. The issue is your cluster secure? Have you prevented unauthorized access? Do you have the right controls in place? Are you using certificates? Who has access to your kube config? In fact, almost no one should have access to that if you're using principles of GitOps at that point. So there are a lot of other considerations that fall well outside of what ambient mesh can control. Like it's not going to save you from your infrastructure challenges. It's going to solve parts of the network challenges that you're trying to solve with service-to-service communication.
Yeah, no, I agree. Like if you're, like Marino says, if you're at the point where your node, your host has been popped, then they'd be in the sidecars the same way they're in the Waypoint and the zTunnel. There's different ways of popping things, right? If they've got something like root access, like access to kind of the kernel, then all bets are off. I guess the thing about the zTunnel and the fact that node local communication does bypass it. There's no MTLS. Like if you get compromised in the sense that somebody can break out of their container, get into the root namespace, like maybe they've got, maybe they don't have the root user, but they're in the root namespace, or they've got privileges to it because you ran a privileged container or you ran in host namespace or something. Then, sidecars will give you mutual TLS on the wire, even locally on the node, whereas the zTunnel doesn't, it gets bypassed. So there's like different ways of it. It's a complicated thing to threat model. And I feel like it gets more complicated to threat model with ambient because the topology gets more complicated. You've got these two moving parts and your topology gets a lot more complicated. It's more difficult to reason about. But yeah, absolutely. Like if you've, like Marino says, there's so many other controls you should be putting in place. We maybe are getting into the weeds a little bit. Well, except unless you're regulated, and the regulator like requires that you have to have TLS on the wire. It's the same with the resources. Like I'd probably want to challenge a bunch of the numbers that have come out around resource usage. I think actually the kernel like helps you. I think sidecars can actually be equivalent to ambient mesh in almost all cases, but by the time you're looking at that, have you actually got the requests for your application right? Have you rewritten the Ruby in Rust? Have you sorted out your HPA and your cluster auto-scaling? Are you using spot instances correctly? What's the stat? Like the average EC2 is 3% utilized. There's so much more low-hanging fruit than looking at that resource question at all. And, if you get there, we can talk about it. But yeah, absolutely. Yeah, I agree with Marino. This is probably not, the low-hanging fruit.
Yeah, I don't know if I misheard something there, or maybe something, I don't know. Someone mentioned node local doesn't go through the zTunnel. Is that one sentence correct?
Yeah, so if you have services that would exist within the same node, right, pod to pod communication won't pass through the Z tunnel. So think of a traditional firewall, and you have a subnet behind that firewall. Do two computers ever pass through that firewall if they're going to talk directly to each other on the network? No. And that's the same situation as to how it works inside of Ambient Mesh with resources that exist on the same node. Now, there are ways to work around that too, but quite honestly, this is where we're starting to get complex, and we start to realize maybe we should start using sidecars again. So this is why it's situational. It's not going to be either or. It's going to be and bits here, bits there, pieces all over, and now you have this like kludge of a messy mesh at this point.
Right. Yeah, I mean, sidecars, were a reaction, I guess. The idea probably came out of Google originally, right, with envelope and whatever, client-side load balancing. They were a reaction, like, firstly to middle proxies, which nobody, I think, has had a good experience with, right? So you do your client-side load balancing instead, in the same way that, like, a Hystrix library or a, like, gRPC fat client does. And also a reaction, like Marino says, to those kind of firewall setups, right, where if you're in a trusted subnet, then any workload in that subnet just talks to its neighbor and doesn't go through the firewall. This is where the whole and that's not sufficient in a bunch of cases. So that's where the whole zero trust thing came from. And there's non-cloud native, non-mesh implementations of this, like Cisco ACI will sell you that kind of dream as well. But the idea is taking that boundary and making it real small. There's still a gateway, there's still a boundary, and there's still a border device. With sidecars, with a service mesh, the boundary is the network namespace. The boundary is the one pod. It's as small as it can be, and the border device is the envoy. And that, I guess, with Z-tunnel, that's what you're kind of giving up, because node local, you don't get that encryption at all. And even if it between nodes, then you're plain text from the application to the Z-tunnel. So you're leaving that network namespace. You're leaving that isolated network and those guarantees. So yeah, it's. You got to understand how it works. It's something to consider when you're looking at the trade-offs.
I'm smiling because you basically brought Cisco into the chat, and it's funny because it's really fun. No, it's great that you brought this up, because back when I was working at VMware under the networking security business unit, we competed heavily against Cisco and ACI, right? But they were talking about the exact same things that we're talking about today. Like nothing. I'll be honest, nothing has changed in networking other than the fact that we're dealing with smaller artifacts. Nothing has changed. You go look at a networking namespace. What is it? How does it get constructed? We're just building, quote unquote, a VLAN at this point, attaching endpoints to it, creating connections to the outside world. And there you go. Now your pods have access to the outside world or other pods. So nothing we've done is different. And it's interesting because I know Cisco and what they're up to right now. And they're breaking into the whole cloud native space. They have like their own CNI. They have an Istio offering as well, or a service mesh offering. But they haven't adopted their own mindset and methodology for those kinds of systems that they're developing for cloud native, which is funny because they're the ones that championed a lot of these architectures that we see today. We're just like repurposing them in cloud native. So it's interesting you brought that up. And, quite honestly, like when I think of companies like Isovalent and what they're doing with Cilium and how they're bringing up service mesh into their own offering, I feel like nostalgia and I feel like deja vu in terms of like going back in time with networking all over again.
Yeah, same. Yeah, the reason I brought ACI because I couldn't actually think of anything else that offered that. I may well be completely wrong, but I couldn't think of anything else.
VMware NSX.
Of course. That's why I worked at Cisco, right? So I guess, that's why I thought of ACI. But that idea of east-west controls without having to like hairpin through a firewall, and it was always a choice, like Marino says, it was always a choice back in the day. We're having the same discussion, like how small do I make my broadcast domains, my VLANs? How small do I make those subnets? Because the smaller I make them, the more traffic goes through the firewall, but then I need to pay for more firewalls and the more administrative overhead I get. So it's the same kind of trade-off. But like I think the difference is with an ACI or an NSX or a sidecar-based service mesh, you can get to that minimal one workload, one Unix process, one network domain, one subnet, and you can have you can get to that proper zero trust. And Z-tunnel is trading that off for other things. But same conversations we've been having, 10, 20 years, even before the NSX stuff, like folks were just buying a lot of firewalls with a lot of ports and making real small subnets, right?
All right. So I love that you also mentioned Isovalent and Cilium, right? Their CNI implementation is purely driven with eBPF and no IP tables. Like, I guess the question just floating around Ether right now, it's like, why is eTunnel in a gateway? Why is eBPF not the choice here?
So I will say that from an innovation standpoint, I don't know how much is going on in the Istio world with eBPF. I know that there's some PRs that are open to use eBPF as an optimization for redirecting traffic. At Solo, we're doing it. So if you decide, hey, I'm done using open source, I need something a little bit more elaborate, and I want to take advantage of eBPF optimizations, well, there is an offering through Solo, through their Glue platform. But having said that, like, even when you look at Cilium and Isovalent, they basically are the ones that pioneered sidecarless through their eBPF offering. Now, having said that, right, when you're looking for completeness of a service mesh, maybe they don't have it all there. It's not all ready. They'll give you parts of it. And if you're already deeply ingrained in using Cilium CNI, I mean, it doesn't hurt to turn on the service mesh functionality and test it out. But then when you're trying to leverage a lot of the capabilities, fault tolerance, resiliency that is built into what sidecars offer, what even sidecarless offers, that's going to be a bit of a challenge working inside of, look, I'm going to say this, but this is just my opinion. A switch that does multi-level or multi-layer networking versus a different control plane that handles specific elements of what a service mesh does. So the way I look at it is, okay, it's nice that you have this single control plane that does it all, but then where do you compromise versus taking the other approach where you use a few control planes that work together to provide you that full stack network, and then you use something like GitOps to control your network or deploy and manage and scale your network.
I think I'd agree with that. Cilium's an interesting one. eBPF is great, right? It's a great technology. It's got a lot of hype. It's not just the networking stuff, right? It's Falco, for example, uses BPF to like hook a bunch of instrumentation points and do essentially EDR. But yeah, like BPF programs can call this XDP library, express data path, and set up fast networking in the kernel. So Istio does use it. I think it's an option. It's maybe default now. Like, don't quote me on that, Marino. You might know. But for the acceleration, when I was saying IP tables before, I mean like the interception of traffic, comes into a pod, comes into a network namespace. It's got to go through the sidecar, back out again. Can be IP tables, can also actually be BPF, and plus XDP, which is usually quicker. I think that might even be the default now. BPF also folks get confused, I think, as the same text used in a couple of places, but yes, Cilium uses it to implement the CNI layer, so to build that overlay network when you're outside of the pod, when you're outside of the network namespace, to build that overlay network in WeaveNet set up tunnels. Flannel relies on you sending your own routes in the host. There's various ways to do it. Cilium uses BPF and gets a bunch of advantages from that. But they are kind of separate. I think to your original question, David, of like, if we have BPF is so powerful and we have it sitting there implementing CNIs, like, why do we need a Z tunnel? One could imagine that a more sophisticated enough networking layer could do that. One could maybe imagine a cloud provider who had a sophisticated, VPC technology might actually be able to replace the Z tunnel or the Z tunnel layer 4 functionality with their own SDN. I couldn't possibly comment, but like you can see how that technology would plug together, right? And then absolutely, that's great. There's nothing wrong with that. So yeah, I think that's going to be an interesting development to watch.
Yeah, so I just wanted to add to that. So there's a company called Merbridge that actually developed the eBPF solution for Istio. And I think the Istio community has decided to adopt that approach altogether. I don't know when it's going to show up. I think there is a PR open for it right now. But that being said, like it's an option. If you are comfortable and are willing to use eBPF for sidecar optimizations, then absolutely go for it. But, the other side to that is if you decide, hey, I want to get fancy with eBPF programming, that might not be the best place to do it because it's pretty static in some ways, right? In terms of that whole configuration stack. The other side to it too is when you start off deploying a service mesh, you don't want to just throw everything at your applications. Start small, right? Maybe you realize that you don't need eBPF to optimize because you don't have a lot of that cross traffic going on. Your latency is not as high as you think it is. So it will come down to a decision point as well. I mean, there's the other side to it too, around stability. Are you going to take something that's been experimental, run that in production? Probably not, right? Which is why Ambient Mesh is still experimental right now. But having said that, I'll plug something. So Istio has officially graduated. In fact, you should see the announcement very shortly, which means there's going to be a lot more traction around the consumption of Istio. You're going to see a lot more vendors pop in and say, hey, maybe we want to contribute more to the ambient side because it fits our model very well. So that's a super exciting thing for us. I mean, the community has poured in a lot of work to make this possible. You see how service mesh and networking in the cloud native space have become prioritized for your workloads. It's become important, much more so than it was 4 years ago. And it's only because of the manipulations you can do inside of both a mesh and a CNI that you weren't able to do before. So it provides a lot of design flexibility in terms of whether or not you deploy ambient, whether you decide you're going to use just the ingress gateway functionality, or maybe I just want to turn on sidecars because I want that observability. I want to be able to do distributed tracing very effectively and see all my different service requests and the paths and see, how these services are tied together and where things are failing, right? So it'll come down to the use cases. There is no one size fits all model. There is no one solution or silver bullet that'll do it all.
No, absolutely. This is why I'm excited about Ambient, right? It's, it's more choice. Choice is always good. And how long's the Istio project been out? I was trying to think, 6 years or something?
6 years, yeah. 6 years.
So, and it's graduated, right? It's in 1.x, 1.18 now. It's pretty mature, but there's still this is a real change. There's real innovation. There's real dynamism. So yeah, super excited to see that happening. Super excited to see the choice. But like Marino says, it's horses for courses. You got to understand what you're turning on. But I would say test it with your own, workloads. Actually look at your own numbers. Do your own threat models. Look at your own regulatory environment. Yeah, David, when you said you were going to just push it to prod, it is alpha still. It is still,
I pushed it during this episode. So.
Well, depends how long you take to edit it. Yeah, but
I do feel like there's some obligatory XKCD that we need to put in here, though. I have to admit, I listen to all this, and sometimes I just kind of think, we have 16 standards. We should have one standard that unifies everything. A couple months later, we have 17 standards. So that's all I kind of think about sometimes when I hear, well, we're using this and that and the other. But it's,
yeah, I mean, gateway API is that.
But I mean, let's be honest. Like you said, networking hasn't really changed. We just changed the scale of it. So maybe there's an XKCD in there as well. Who knows?
But I think, like Marino says, folks are. I personally feel like we're getting more mature. The actual cloud native thing, right? Folks were going into the cloud, and I was at various consultancies and whatever, and we were always saying you've got lifting and shifting, being in the cloud is not enough. You've got to be cloud native. And I think the sort of lift and shift, or the naive cloud architectures happen for a lot longer than I maybe thought they would. And folks are now realizing that they've got all their microservices and all of this, and it's great, and they've built a distributed system. What used to be one monolith with dependency injection and an ORM, and we got quite good at building monoliths, right? Really, with interface driven design and stuff. And if namespace A equals namespace B, it can't fail. You're just putting a program counter on the stack and calling jump, right? Basically instant, never fails. You've now built a distributed system. You've probably got distributed transactions. You've got failure modes you never thought of. And the network is the way to fix that, right? So I think we're finally becoming actually cloud native in this, exactly like Marino says. We've got to realize we need to leverage there's a whole bunch of stuff. We've got to get that observability back that we had by just attaching a debugger to our massive process. We've got to get the control back that we had with dependency injection systems and the sort of, different routing they could do in test builds. And a service mesh is I think the way to do that. And so networking and meshes are coming forefront as people realize that they absolutely need this stuff, and you can't build a system properly without it. So so as somebody who's always been into networking stuff, it's fun to see.
All right, we're very, very close to the end of the hour. So I'll now give you both the opportunity just to shamelessly plug anything you want. So feel free to take, a couple of minutes, whatever you need, to share your Twitter, your website, your company, your products, your OnlyFans. Go for it. Have fun. Marino, why don't you take it away first?
Yeah, so if everyone can see the video, I've thrown my Twitter handle on there, so you're welcome to kind of see some of the shit posts that I put out there about networking and perspectives and even service mesh. But one thing that I noticed last year was that there was a lack of understanding of how networking worked inside of Kubernetes. And I, sought out to build a workshop, built the workshop, delivered it a few times, and it's become a thing. So if you really want to understand what's going on in the OSI model, I've built a workshop called Network Foundations. It can be accessible at academy.solo.io. Head over there, register, and then you can take the workshops in 2 parts. You get the first bit that covers, IP addressing, subnetting, understanding routing, DNS, and even working with a little bit of HTTP. And then the second part focuses in on why we use proxies, how to set them up so that you could start doing things like load balancing or filtration of packets or traffic, all the way to understanding how networking namespaces are built and why you wouldn't do this today. Instead, you'd use a CNI because it takes care of all the IP address management and the onboarding and offboarding of pods. And then we end at Kubernetes networking to understand how pods communicate on a network in Kubernetes and how we expose them to the outside world. So go check it out. academy.solo.io, Network Foundations.
All right, your turn, Matt. Yeah.
Do you want me to screen share the OnlyFans or?
There we go. Let's do it. Right. In this visual medium of a podcast, it's going to be great.
Yeah, maybe I won't get
It's on YouTube too. It's fine, but we'll also put the link to the course on your Twitter in the show notes as well.
You can
add your OnlyFans, Matt.
But go for it, Matt.
Yeah, cool. Yeah, so I'm Matt Turner. If you do want to follow my shit posts, fairly similar flavor, I guess. I'm at MT165 on Twitter, and there's links for there to the other nascent socials that are coming along. I've done a fair amount of talks. I've got a website, mt165.co.uk, that's got links to the videos with all of those. I talk about networking and service mesh and Kubernetes and stuff. I work at Tetrate, so we have a management plane. We didn't get into it, but we've got a management plane over various Istio control planes. So all the stuff we were talking about, where do you, which control plane do you use? Where do I configure layer 4 versus, layer 7? How do I use Istio CNI policies Kubernetes CNI, like network policies, in addition with Istio features. The management plane kind of transparently takes care of all of that. And we've also involved in a bunch of the open source projects. So we're big into the new gateway API stuff, which I think is super exciting for everybody. And hopefully, is the 17th standard that will actually replace them all, because it is looking really good. Istio supports it. Lots of other stuff is supporting it. So that's exciting. And we're the main contributors to the reference implementation of that, which is like Envoy Gateway, like real simple ingress gateway based on Envoy, talks to Gateway API, should hopefully become the de facto standard there. And we do WASM stuff as well. So if you want to plug WASM into Go, if you want to build Go into WASM, all of those tool chains are other things that we're working on. So yeah, we're helping out the ecosystem in a bunch of different places there.
Cool. David, considering that I just heard your keyword, WASM.
WASM. Yep.
WASM. There we go. It's your turn.
Are you plugging?
No, I'm just saying. I know. I'm just having fun teasing about WASM.
I could just run an episode where I talk about a cool lipophile.
Hey, you did really, really good. You didn't get into it the whole time. It
was
good.
I was going to say something about it, but very I did think done. That's a bit of a rabbit hole. Yeah, Marino's totally right about the network becoming powerful and a big lever, but please don't put business logic there. We've done this before with ESBs. We've done it before with Lua scripts in your Nginx reverse proxy. WASM gives you this amazingly powerful tool and a great big gun to shoot yourself in the foot. Please don't use BPF or WASM to hook the network with business logic. That's all I'm going to say on that.
I mean, if we don't learn the history,
right,
what are we doomed to do? So
you need a bunch of grumpy people on a call like this to tell you how bad it was.
Yeah, exactly.
I mean, didn't they try that without WebAssembly with cloud native network functions? Where every network thing was supposed to be a container? That was the thing for 2 minutes, right?
There's so many ways to do it.
There's also people who trudge up the uphill in the snow both ways. We can argue about that. That'd be fun. But thanks for joining us.
If you want to keep up with us, consider subscribing to the podcast on your favorite podcasting app, or even go to cloudnativecompass.fm.
And if you want us to talk with someone specific or cover a specific topic, reach out to us on any social media platform.
Until next time, when exploring the cloud native landscape, on 3?
On 3.
1, 2, 3. Don't forget your compass.
Don't forget your compass.